Hello everybody, today we are going to start with a new chapter that is force and laws of motion. In our everyday life, we observe that some efforts are required to put a stationary object into motion or to stop a moving object. We ordinarily experience this as a muscular effort and say that we must either push or hit or pull on an object to change its state of motion. The concept of force is based on this push, hit, or pull. So, we can define force as any action which causes push, hit, or pull on a body is called force. Force cannot be seen, but it can be judged only by the effects which it produces in various bodies around us. Some of the effects of force are a force can move a stationary body. For example, a bicycle at rest starts moving when we pedal it. A force can stop a moving body. For example, a car stops when brakes are applied. A force can change the direction and speed of a moving body. For example, when a batsman hits the ball, the direction and speed of ball changes. A force can change the size and shape of a body. For example, while making chapatis, the size and shape of the dough changes. There are many forces acting around us, for example, gravitational force, frictional force, magnetic force, muscular force, etc. etc. But today we are going to study about two forces. One is balanced force and another is unbalanced force. So what is a balanced force? When the net effect produced by a number of forces acting on a body is zero, it is called balanced force. Say for example, in a tug of war, none of the teams is able to win as long as equal forces exist from both the sides. Whereas when the net effect produced by a number of forces acting on a body is non-zero, then such forces are known as unbalanced forces. For example, in a tug of war, when one team applies more force than the other, there is movement on one side. Now we come to Newton's laws of motion, that is the most important topic of this chapter. Newton studied the idea of Galileo regarding the motion of an object. He formulated three fundamental laws that govern the motion of objects. These laws are also known as Newton's laws of motion. We are going to study Newton's first law. It states that an object will continue to remain in its state of rest or in a uniform motion along a straight line or path until an external force acts on it. You can understand it using an example. Say if suppose a book is lying on a table undisturbed. Is it going to move on its own until and unless an external force acts on it? No, it is not going to move. And say for example a vehicle, it is moving at a uniform speed in a straight line. Is it going to stop until and unless brakes are applied? No. So this is what the Newton's first law states, that if an object is at rest, it is going to remain at rest until and unless an external force acts on it, and the same is the case when the object is in motion. Say for example a moving vehicle is there, it is moving with constant speed in a straight line or path, then it is not going to stop on its own until and unless an external force, brakes, are applied. So this Newton's first law, it implies that all the objects they show resistance when it comes to changing their state. When it is in a state of rest, it is going to remain it in a state of rest, and if an object is in a state of motion, then it is going to remain in its state of motion until and unless an external force acts on it. Let us now see some real life situations where Newton's first law is applicable. A person standing in a bus falls backward when the bus suddenly starts moving. This happens because the person and the bus both are in rest while the bus is not moving. But as the bus starts moving, the legs of the person start moving along with the bus, but rest portion of his body has tendency to remain at rest. Because of this, person falls backward if not alert. Second one is a person standing in a moving bus falls forward if driver applies brake suddenly. A person in a moving bus continues to be in the state of motion along with the bus, but when brakes are applied, bus comes in a position of rest. However, the person remains in a tendency of motion, so a person tends to fall forward in such a situation. Next topic is inertia and mass, and this definition of inertia is asked very frequently in the exam. So make sure you do it thoroughly. Inertia is the unwillingness or the inability of an object to change its state of rest or of uniform motion. Or you can also say that the tendency of a body to remain in its state of rest or of motion is called inertia. Newton's first law is also called Galileo's law of inertia. Inertia of an object is measured by its mass. Inertia is directly proportional to mass of an object. If the mass of an object increases, then the inertia also increases, and if the mass of an object decreases, then its inertia also decreases. For example, if you look at a small stone, it is having little mass, it is not going to have much inertia. But if you look at a big rock, it is having huge mass, so it will have a large amount of inertia. It means if it is in a state of rest, a large rock, then it will be very difficult to move it. A large amount of force needs to be applied in order to move it, because it is having more inertia, more tendency to remain in its state of rest. Whereas if it is a small stone, you are going to hit it once and it is going to start moving because it is having small mass. So smaller is the inertia, it is very easy to move it by applying a little force on it. Inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. We are first going to see inertia of rest. The tendency of a body to oppose any change in its state of rest is called inertia of rest. For example, when a bus suddenly starts moving forward, then the passengers in the bus fall backward. The carpet is beaten with a stick to remove the dust particles, and when a tree is vigorously shaken, then some of the leaves fall from the tree. This is all because all these bodies were in a state of rest, and when suddenly external application of force is there, then they show movement. Second one is inertia of motion. The tendency of a body to oppose any change in its state of uniform motion is called inertia of motion. For example, the passengers fall forward when a moving bus stops suddenly. This is because the passengers are in a state of motion along with the fast moving bus. But when the bus stops suddenly, the passengers tend to fall forward. The last one is the inertia of direction. The tendency of a body to oppose any change in its direction of motion is known as inertia of direction. For example, when a fast moving bus takes a curve on the road, then passengers fall away from the center of the curved road. This happens because the passengers are having a tendency to move in a certain direction, and when the direction of the bus changes, it makes them fall away from the center of the curved road. Similarly, the sparks that are produced during sharpening of knife against a grinding wheel leave tangentially to its rim. A stone that is tied to string is whirling in a horizontal circle. If the string breaks, then the stone flies away tangentially. This is all happening because of inertia of direction, because the objects were in a tendency to move in a certain direction, and when the direction changes, this is how they change their movement. Our next most important topic is momentum. Momentum measures the quantity of motion that is possessed by a body. It is defined as the product of mass and velocity of the body. Besides magnitude, momentum also has direction. At any instant, its direction is the same as the direction of velocity. If a body of mass m moves with a velocity v, then momentum p is given by p is equal to m into v. It means mass into velocity. The SI unit of momentum is kg meter per second, because kg is the unit of mass and meter per second is the unit of velocity. So, the unit of momentum turns out to be kg meter per second. If a body is at rest, then its velocity v is equal to 0, and so the momentum p will also turn out to be 0. Newton's second law of motion. The second law of motion states that the rate of change of momentum of an object is proportional to the applied external force and takes place in the direction in which external force acts. We now come to the mathematical formulation of second law of motion. Say suppose that we are having a body of mass m that is moving with an acceleration a, time is given by t, initial velocity is denoted by u, and final velocity is denoted by v. So initial momentum will be p1, that is given by m into u, mass into velocity, and the initial velocity is u. Final momentum is denoted by P2. It is given by m into v. M is the mass of the body and v is the final velocity. Change in momentum will be P2 minus P1. It means final momentum minus initial momentum. It will be given by mv minus mu. Take m common, you will have m into v minus u. Now according to the second law of motion, we have force is directly proportional to change in momentum per unit time. It means you can also say F is directly proportional to P2 minus P1 upon T. You can write this as F is proportional to m into V minus U upon T. Now in place of this V minus U upon T, you put A. A is acceleration. This has come from first equation of motion chapter. So you can write F is directly proportional to m into A because now we have replaced V minus U upon T by A. You will have F is equal to K into m into A. If you remove the sign of proportionality and put an equal to sign, K will be introduced, that is a constant of proportionality. So you can say that 1 unit force is equal to K into 1 kg. If you take mass is 1 kg into 1 meter per second square, the unit of acceleration is meter per second square, and we are taking 1 meter per second square over here for the sake of convenience. So this K will turn out to be 1 because everything is 1 now. So force will turn out to be F is equal to m into A. So the SI unit of force is Newton, and 1 Newton is equal to 1 kg meter per second square. What is 1 Newton? 1 Newton is defined as the amount of force that produces an acceleration of 1 meter per second square on an object of mass 1 kg. When force applied is 0, then acceleration is also 0 and the body remains in its state of rest or of uniform motion. Applications of Newton's second law. A cricket player moves his hands backward while catching a fast cricket ball. A fast-moving ball has a large momentum. When the player moves his hand backward, he takes more time to stop the ball. Since force and time are inversely proportional, using this formula, force is proportional to m into v minus u upon t. So when time increases, force decreases. Therefore, a small force is exerted on the hands of the player, and this is how he saves himself from getting hurt. Similarly, during athletics meet, athletes doing high jump and long jump land on the foam or a heap of sand to decrease the force on the body, and the landing becomes comfortable.